Hi, this is your Lucky sir. Now we are in Thermodynamics worksheet 2. Fine. Conceptual questions we are solving. We are trying to understand the basic lines of thermodynamics. See question number 26. 1 to 25 questions are in worksheet 1. You can check that. For N2 plus 3H2 gives rise to 2 ammonia, enthalpy and lattice internal energy changes are respectively delta H and delta U. Then see here, this is gas, it is again gas, it is gas. So delta N is equal to number of moles of gaseous products minus number of moles of gaseous reactants, 1 and 3, 4. So it is minus 2. The relation between delta H and delta E is known to you. Delta H is equals to delta E plus delta nRT. So this is delta H is equals to delta E minus 2RT. So delta H is less than delta E or delta U. Clear? Simple question. According to IUPAC convention, which one of the following is not correct? He is asking about not correct. Don't confuse. The heat absorbed by a system is taken positive. Correct? Heat absorbed is always positive. If a system is accompanied by a decrease in energy, delta is negative, right? It is energy is going out, so delta is negative. The work done by the system is taken as negative. Work done by the system is always negative. So, which is not correct? All the above three statements are correct. So, what we need to take? The heat absorbed by the system is taken positive. Okay, for this kind of questions, okay, now, funny because chemistry teachers may not know English properly. Then it goes. If we take this option, what does it mean? All the above three statements are correct. Is it not correct statement? Funny, all the statements are right. Okay, so I'm sorry for this option. During expansion of a gas into vacuum, P external is 0. Vacuum means P external 0. Work done is 0. Right? Work done is 0 in any process. Reversible process, irreversible process, isothermal process, any process, because external pressure is 0. When external pressure is 0, all process energy is 0. Internal energy, work done is 0. Sorry. Mathematical form of first law. According to first law of thermodynamics, whatever the heat you are giving, that will be useful for work done and remaining is for internal energy change. Heat you are supplying, this is internal energy change, this is work done. So this is the right option. About entropy and all we'll discuss in second. So coming to 30th question. Up to 50th question we'll discuss now, right? Get ready. Slowly. Okay now. Aram se. If you feel bored, stop here. After some time again you join back. You don't feel bored, I'm sure, right? A system absorbs X joules of heat and does Y joules of work. Its delta is positive when? See, delta is positive and he is asking X joules of heat is absorbed. Okay, now X is absorbed and Y is work done by the system. So this energy is going out. This energy is coming in and he is saying delta E is positive. That means X must be greater than Y. For example, that means you are a system. To you, I am giving you 60 joules of energy. That is X. And you are doing 50 joules of energy. This is Y. This is going out. And this is coming into you. This is going out of you. So what is net energy? 10 joules. Your internal energy is increased. Right? Correct. In an adiabatic expansion of ideal gas, work done is equals to minus delta E. What is the meaning of this? Adiabatic means between system and surrounding no heat exchange is possible. That means Q is equals to 0. We are not giving any heat. And expansion means work is done by the gas. Gas expanded, work is done by the gas. So who is giving energy? Okay, now to expand, some energy is required and that energy is coming from the internal energy. By consuming some internal energy, the system is working. Okay, the gas is working. In adiabatic process, Q is equals to 0. No heat exchanges are there. That means it is not taking energy, it is not losing energy. So whatever the work is done, that is by utilizing its own internal energy. Option 1. One good conceptual question. During isothermal expansion of ideal gas, its internal energy decreases, increases, may increase or decrease and remains unchanged. Why? During isothermal expansion, delta T is equals to 0. When delta T is equals to 0, internal energy of the gas molecules are taken as kinetic energy. Because in ideal gas, there are no attractive forces. When there are no attractive forces between the molecules, the potential energy is 0. So whatever the energy is there, that energy is nothing but kinetic energy. And kinetic energy, we know this is 3 by 2 nRT for the gas molecules. When temperature is constant, delta T is equal to 0 isothermal process. When temperature is constant, kinetic energy is also constant. That means internal energy will be unchanged, constant. Very good question. For the gaseous reaction involving the complete combustion of isobutane. See here, gaseous is mentioned. Isobutane, you should know what is isobutane. Butane is nothing but isobutane. Formula C4H10 6.5O2 4CO2 5H2O. He mentioned here gaseous reaction means all gases, gas, and gas. Number of moles of products are 9, 4 plus 5. Number of moles of reactants are 6.5 and 1, 7.5. So this is positive. When delta N is equals to positive, imagine what happens. What is the relation between delta delta H and delta E? Delta H is equals to delta E plus delta nRT. And delta N is now 1.5. That means delta H is greater than delta E. Or delta E is greater than delta H, which is right. This is number of moles are 9 and these number of moles are 7.5 sorry. So positive number of moles are there 9 minus 7.5. Gaseous phase reaction means you take all gases. Okay now. So 4 plus 5 and this is 6.5 and 1. So balance it now. You can check. 4 to the 8 plus 5, 13 oxygens are this side. And this side 6.5 O2 means, that is 6 O2 means 12, 6.5 means 13. So 13 oxygens, everything is balanced. Now delta N is positive means delta H is equals to delta E plus delta nRT. So delta H is greater than delta E. Correct? So don't confuse with that one. Delta H and delta E relation. If somewhere you feel that I have confused, nothing, no problem. Go with another question, right? Which are the following is an exothermic reaction? What do you mean by exothermic reaction? Exothermic reaction means heat released. Heat released, you see, here 180.8 kilojoules of energy you need to give along with this. That means N2 and O2 should be supplied this one. So this is endothermic. In this case, you see, plus minus 92 is given reactant side. That means when it is coming this side, it will become plus 92. When it is plus 92, that means along with ammonia, this much of amount of energy is released. So this is exothermic, 100% right. Graphite plus H2O, CO, H2, here minus is there. Here minus is there means delta H is positive. Or use your common sense, this must be this side plus, means you have to give 131.3 kilojoules for this reaction. So this is again endothermic. Here same thing, here minus is there means it is again endothermic. Similar. 2-3 questions if you solve like this, you can feel very much comfort. Which of the following is an endothermic reaction? See, here minus means this side it will become plus 92. means it is exothermic. Here plus 180.8 is there. So when it comes this side, it is going to be minus 180.8. Or along with N2 and O2, you need to supply this much of energy. This much of energy you need to provide. So this is your endothermic change. What about this one? Delta H is negative means exothermic. So here in the equation place is there means along with methane, this much of energy is coming out. So delta H is negative. So this is also exothermic. Simple logic. You can answer all this easily. Which of the following is an exothermic reaction? Delta H negative, exothermic reaction. Delta H positive, endothermic reaction. In the equation, it is given here minus. Okay, that means it is delta H positive. In the reaction, this side is given plus. Okay, and that means you need to give along with graphite and sulfur, you need to supply this much of amount. So delta H is positive, or you can say endothermic. So right option is, which of the following reaction do you think will result in the absorption of heat? Absorption of heat means he is asking about endothermic, right? We'll check the options. Carbon burning in air, C plus O2 CO2 gives rise to, this reaction is 100% exothermic. Why? All combustion reactions are exothermic. Combustion means burning in air. Combustion reactions are 100% exothermic. Iron reacting with sulfur to form iron sulfide. Okay, now iron sulfide, FeS or FeS2, Fe2S3, all possibilities are there. Formation of water gas from steam and coke. See, steam very hot, coke when they are reacting, this is definitely endothermic. Okay, now water gas formation, I think you remember C plus H2O gives rise to CO plus H2. You will get this in your group 14 elements. This combination is called water gas. Water gas is a fuel. So coming to 38, देख लो एक बार 38 क्वेश्चन क्या दिया गया है. The formation of water from H2 and O2 is an exothermic reaction because here you need one simple graph, man. See, if this is reactants, potential energy I am taking here, and this is product. Energy of the products is more than reactants. This is endothermic. If the graph is given like this, reactants energy, products energy, here we are taking potential energy. If the products energy is less, that is exothermic. Use the simple line. Here he is saying exothermic reaction. Means like this. Reactants energy is more than products energy. H2 and O2 have a higher chemical energy than water. These graphs are very, very important, you remember. And this gap is known as delta H. This gap is known as delta H. This is threshold energy, this line. And this is called activation energy. All this you are going to learn in chemical kinetics. So coming to this point, when a solid melts, क्या होता है? एक solid जब melt हो गया तो there is an increase in enthalpy. Solid melting is endothermic change. Endothermic change means delta H is positive. Increase in enthalpy. Coming to heat of formation questions. The enthalpies of elements under the following conditions are assumed to be. Okay, now standard conditions we say. Standard conditions 0 at 298 Kelvin and 1 atm. Carbon, graphite, sulfur, rhombic sulfur, all these are taken as 0 at 298 Kelvin and 1 atm. H2 gas, F2 gas, Cl2 gas, all these also. Under those conditions, the enthalpy is taken as 0. Remember, that is very, very important point. For which of the following elements the standard enthalpy is not 0? Just now we are discussing. Na? Carbon, graphite is the standard element. Rhombic sulfur is liquid mercury is, it is not. Diamond is not the standard form of the carbon. Standard form of the carbon is graphite. The enthalpy of elements in their standard states are taken as 0. Hence, the enthalpy of formation of compound is okay now. So, compound formation may be positive or negative. Enthalpy of formation may be negative or positive. If you want to get negative answer, then enthalpy of combustion you can take, enthalpy of neutralization you can take. Enthalpy of neutralization, enthalpy of combustion are always negative. Remaining, anything is possible. In which of the following reactions heat liberated is known as standard heat of formation of CO2? What is the concept here? Standard heat of formation means the compound should form from its constituent elements in the native state form. Okay na? So diamond is not considered, carbon monoxide is not considered, methane is not considered. Which is right? Graphite plus O2 gives rise to CO2. This is the right form. Here this energy is called heat of formation. Identify the reaction in which the heat liberated corresponds to heat of formation. So one mole concept is there. Na? Diamond not accepted. 2 moles not accepted. 1 mole only should form. Diamond not accepted. Sulfur, rhombic sulfur is accepted. Okay, now SO2 formation. It must come from its constituent elements. The heat change for the following reaction is known as, you can check here. CS2 is coming from carbon, solid, nothing is mentioned, means you can take it as graphite. Sulfur solid, that is rhombic sulfur. If it is not mentioned, you feel that I am giving you. So that you can say heat of formation. Which of the following represents delta HF naught? Means again formation. Formation means 1 mole only should form. 1 mole should form. Not from diamond, so this is gone. Here 2 moles are there, so this is gone. Carbon monoxide, carbon should come from carbon, so this is gone. So remaining is, this is the right option. Half H2 plus half F2 gives us HF, only 1 mole is formed. If they give you H2 plus F2 gives us 2 HF, this is not possible because 2 moles are forming. Got it? I think now you are very much comfortable with the heat of formation. Correct. That's why we always say try to solve maximum questions than reading the concept. Go with the questions. Okay now. Which of the following equation represents standard heat of formation of ethanol? Ethanol is C2H5OH. What elements are there? Carbon, so it should come from graphite. Hydrogen, it should come from hydrogen gas. Oxygen, it should come from oxygen gas. Check once, which is right. Graphite, hydrogen, oxygen, C2H5OH is right option. Diamond is there, so sorry. Here gas is there. C2H5OH will be formed in the liquid state. This is again not possible. The reaction which shows standard heat of formation of water. Water means H2 plus R4 gives rise to H2. This is solid, not possible. Gas, not possible. 2H2 plus 2H2, 2 moles of H2O, not possible. So this is your option. 1 mole of H2O in the liquid state coming from constituent elements. So the heat is called heat of formation. 2 more questions we'll check and we'll take a short break. Short break of some 10-20 hours. Right? So the enthalpy of the reaction. H2 plus R4 gives us H2O. Delta H1. H2 plus R4 gives us H2O. This is gas and this is liquid. Delta H2. Then enthalpy of the reaction. See, here only liquid is formed and here liquid you need to go to gas. So here some amount of more energy required from liquid to gas. H2O formed from H2 and O2. Gaseous state means this is more energy form and this is little lesser energy form. So delta H2 to delta H1 again we need to take it little more. So delta H2 is greater than delta H1 because up to here some amount of energy will be released because this is highly exothermic, we were discussing just now. But here after liquid to gas this is endothermic. So some amount of energy will be wasted here. So this is greater value than that one. So this is one very good question. Coming to the last question of this session, the chemical process involved in the combustion reaction is combustion reaction always redox reaction. For example, CH4 combustion reaction, CO2 plus H2. Carbon here, how it changes, or magnesium you take, combustion reaction, MgO, magnesium zero oxidation state, here it is plus 2, oxygen zero oxidation state, here it is minus 2. So both changes will be there, so it is a redox reaction. So thank you for listening this class up to this place. If you really like this, share with your friends. I want to see maximum students in my list. Okay. Thank you. Signing off, Lucky Sir. 51 to 75 in next video I will post by tomorrow.